Hi everyone. Today we will be solving problems on vector calculus. So let's begin. First question is the line integral of the vector from the origin to the point P is. So by inspection we find that V is equal to 2xyz x square z x square y, which is 2xyz I cap plus x square z j cap plus x square y k cap, which is equal to gradient of some function v, where v can be found out by integrating. So by integrating we get v as x square y z. So you may integrate this x component with respect to x and this y component with respect to y dy, and then x square y with respect to z. So you will get x square yz. Right? Now, since this is the problem on independence of path, so to find the value of integral, the line integral of the vector function, if this is we have point O as 0, 0, 0 origin and point P as 1, 1 and 1. So line integral of the vector function from point P to origin will be, from origin to the point will be f of P minus of f of O. Yes, so x square yz, putting the values of P and O in x square yz, so we will have 1 minus 0, that is 1 as the answer. I have selected few more problems on independence of path. Then you will get more clear concept on independence of path. Okay, let's go to the next question. Value of the integral where C is the square cut from the first quadrant by the lines will be, use Green's theorem. So we have to use Green's theorem to change the line integral into double integral. So what Green's theorem says is, you have two continuous functions phi and psi, which is equal to double integral closed bounded region R and two continuous partial derivative d psi by dx minus d phi by dy dx dy. Let us compare with the given data. You are given to find value of integral. So here phi is minus y square, phi is minus y square and psi is xy. Yes, and let us draw the region R, which is a square cut from the first quadrant by the lines x is equal to 1 and y is equal to 1. Let me show you this through graph. So if this is y axis, this is x axis. So you have x is equal to 1 and y is equal to 1. Okay, this must be a square. So y is equal to 1. Right? This point is 1, 1 and this is 0, 0. right? So here, since phi is minus y square, so d phi by dy partial derivative will be equal to minus 2y, and d psi by dx will be equal to y, because we are differentiating xy with respect to x. Okay, so now substituting in the Green's theorem, we get double integral y minus of minus 2y dx dy, where x varies from 0 to 1 and y varies from 0 to 1. Now evaluating this, we have 3y dx dy. Of course, x is equal to 0 to 1 and y varies from 0 to 1. So we have, let us first differentiate, integrate with respect to x, right? So this is 3xy, where x varies from 0 to 1, right? So y is equal to 0 to 1, 3y dy, which is 3 by 2. So 3 by 2 is the answer. Okay, let's go to the next problem. Here we have to find the directional derivative of at the point in the direction of the vector. So we need to find A by mod A, gradient f. Yes. So here f is given as 2x square plus 3y square plus z square. So, and A is given as 1i minus 2k. Okay. So let us find gradient f. So which is del f by del x I plus del f by del y j plus del f by del z k. Okay, so 4x I plus 6yj plus 2zk. Yes, 4xi plus 6yj plus 2zk. At P, del f is equal to, by putting values of x, y and z respectively, we have 8i plus 6ij plus 6k, right? So directional derivative of f in direction of vector A is nothing but the component of gradient f in the direction of vector A, which is given by A by mod A to gradient f. So now we have the values. So I minus 2k root under 1 square plus minus 2 square times 8i plus 6j plus 6k. That is 1 by root 5, 1.8 plus 0.6 minus 12, which will be minus 4 by root 5. Minus 4 by root 5 is equal to minus 1.789. Right, so C is the answer. Okay, let's go to the next problem. Consider points P and Q in the xy plane with P and Q the line integral along the semicircle with the line segment PQ as its diameter. So this is again the problem on independence of path. So taking F, we have F given as x dx plus y dy xi and yj, right? So which is equal to gradient f, where f is by integrating x, y, right? So the value of integral is independent of path. So to solve this, we have formula as f1 dx plus f2 dy, okay, so is equal to f3 dz. Since here we have only x and y component, so we will omit f3 z component. So is equal to f of b minus f of a, where f is equal to gradient of f. Yes. So integral f of q minus f of p, right? Q is given as 0, 1 and p is 1, 0. So is equal to xy 0, 1 minus xy 1, 0. So which is 0 minus 0 is equal to 0. So you can verify this by, since you can directly integrate, we have x dx plus y dy. Okay, so x dx plus y dy. So separate the integral. So 1, 0 and 0, 1. So there is 2. So which is equal to 2 times x square by 2, 1 to 0, minus y square by 2 and 0 to 1. So which is 0. So verified. Let's go to the next problem. A sphere of unit radius is centered at the origin. The unit normal at a point on the surface of the sphere is the vector. So unit normal is given as vector v by modulus of vector v, or magnitude of vector v. So we have xi plus yj plus zk cap. Okay, so since root under x square plus y square plus z square is nothing but the radius of the sphere, which is 1. Okay, so unit normal will be xi plus yj plus zk cap. right? So x, y and z. So this is the right answer. So since we have to find line integral, so we know Green's theorem is the transformation between surface integral and line integral. So according to the Green's theorem, if R is the closed region of xy plane and we have two continuous functions phi and psi, so E is equal to R is the closed region and C is the simple curve, then and we have partial derivative d psi by dx minus d phi by dy. Okay, so this is Green's theorem. Now given vector is xy ax cap plus x square ay cap and A dot dl is given as so xy dx plus x square dy, so dl is dx ax cap plus dy ay cap plus dz az cap, right? So now using Green's theorem, we have psi as x square and phi as xy. So now d psi by dx is 2x and del phi by del y is x, right? So now putting the values, we have d psi by dx minus del phi by del y dy dx, right? So we have two x minus x dy by dy dx. So where y is varying from, see here, 1 to 3 and x is varying from 1 by root 3 to 2 by root 3. So let's put the limit, let's set the bound, which is y is equal to 1 go 1 to 3 and x is equal to 1 by root 3, varies from 1 by root 3 to 2 by root 3. Yes. So now simplify x, y, 1, 3, 1 by root 3 to 2 by root 3 dx, right? So which is 2x dx, again x square 2 1 by root 3 to 2 by root 3. Right? So we have 4 by 3 minus 1 by 3, which is 1. So 1 is the answer. Okay, next move to the next problem. The line integral for, okay, 2 points are given along the semicircle shown in the figure is. So this is the same problem as before. Just the thing is, points are not specified. So let's see this question, right? So consider points PQ in the xy plane. Here points were given and we had to find line integral along the semicircle with the line segment PQ as its diameter. Okay. So this is a semicircle and you can say that P1 and P2 is a diameter. Right? If P1, P2 is a semicircle, so we can say that P1, P2 is a diameter. So here, simple, using Green's theorem we have xy okay, x1 y1 and x2 y2, so which will be x2 y2 minus x1 y1. So this is the answer, A is the answer. Okay, so let's go to the next problem. If A and B are two arbitrary vectors with magnitudes A and B respectively, then this will be equal to. So let A cross B is equal to modulus A modulus B sine theta, and obviously n cap since cross product is a vector quantity, and again A cross B modulus square is equal to modulus B square sine square theta and n dot n. Again we can replace sine square theta by 1 minus cos square theta. Yes, and n dot n is 1. Okay, so we know that A dot B is equal to A B sine theta, sorry, cos theta. So cos theta can be written as A dot B by modulus A and modulus B. So we will use this, right? So A square B square 1 minus A dot B by modulus A modulus B, right, whole square. Okay, so now if you simplify this, so you will have A square B square minus A dot B square, so which is A square B square minus A dot B square, right? So answer will be A. Okay, so let's go to the next question. The direction of vector A is radially outward from the origin, with A is equal to k r raised to the power n, where r square is equal to x square plus y square plus z square and k is a constant, the value of n for which del dot A is equal to 0. Since vector A is radially outward from the origin, we can write A vector as k r n a r. Okay, so in spherical coordinates we know that divergence of a vector is given as 1 by r square del r square ar del r plus 1 by r sin theta del by del theta a theta sin theta plus 1 by r sin theta del by del a by del phi. Okay, so here we have only the radial component ar, so these theta and phi components are 0, so we have 1 by r square del by del r square k times r raised to the power n. Okay, so again you can write this as 1 by r square. You can take k out, so k by r square del by del r and r raised to the power n plus 2. Yes, so now differentiating n plus 2 r n plus 2 minus 1, so which is 1 n plus 1. So now for del dot a to be 0, n plus 2 must be equal to 0. Okay, from this, so now n is equal to minus 2. Okay, so let's go to the next problem. The following surface integral is to be evaluated over a sphere for the given steady velocity vector field f defined with respect to a Cartesian coordinate system having I, j and k as unit base vector. So where S is the sphere with a unit radius and n is the outward unit normal vector to the sphere. So the value of surface integral is. So you need to find here surface integral. So we can use divergence theorem. So we can make use of divergence theorem, which is transformation between volume integral and surface integral. So f dot nda is given as, okay, where n is the unit normal vector and divergence of f dv. Yes, here f is given, okay, xi plus yj plus zk. So we know that this is a position vector and divergence of a position vector is 3. Let me show you. Okay, so dx by dx plus del y by del y plus del z by del z. Okay, since x, y, z component are x, y and z respectively, so which is equal to 3. Okay, so del dot r is equal to 3. I mean, for here in this question del dot f is equal to 3. Okay, so we have now divergence f as 3. Okay, so we need to find 1 by 4 surface integral 1 by 4 f dot n dA. So let's take 1 by 4 out and now we can write divergence f, which is 3. So 3 dv. Now obviously this is a volume integral, so 3 by 4 taken out, and you know we are given the sphere with unit radius. So what is the volume of a sphere? 4 by 3 pi r cube. So 4 by 3 pi, our radius is 1, so we have answer as pi. Okay, so the value of surface integral is nothing but pi. Let's go to the next problem then. Given a vector field f, the line integral evaluated along a segment on the x-axis from x is equal to 1 to x is equal to 2 is. We have to find f dot dl along a segment on the x-axis from x is equal to 1 to x is equal to 2. So y is equal to 0 and z is equal to 0. Since the segment lies on the x-axis, so y is 0 and z is 0. So we can write f dot dl as, so y square ax minus yz ay minus x square az cap dot dl as ax dx plus ay dy plus az dz. Okay, so now again y squared ax integral, so integral, sorry, it is y square x here. So now y square x ax cap dot ax cap dx, which is y square x dx, and minus yz ay cap dot ay cap dy, which is minus yz dy, again minus x square az cap dot az cap dz, which is az cap x square dz. So now since we have y is equal to 0, so dy is also 0 and dz is also 0. Okay, so we have y square x 0, this is 0, this is 0, and okay, so this reduces to 0. So f dot dl is equal to 0. 0 is the right answer. Okay, let's go to the next question. A vector is defined as where I, j, k are unit vectors in Cartesian coordinate system. The surface integral over the closed surface S of a cube with vertices having the following coordinates is. So let us first locate the vertices on xyz plane. Say this is x, this is y, this is z. Okay, so we have 0, 0, 0. And 1, 0, 0. So 1, 0, 0. 1, 1, 0. 1, 1, 0. 0, 1, 0. 0, 1, 0. 0, 0, 1. 0, 0, 1. 1, 0, 1. 1 0 1 1 1 1. It will must be somewhere here. 1 1 1 and 0 1 1. So 0 1 1. Let us join these points. Right? So f is given. So since we have to find surface integral, so we will use Gauss divergence theorem here. So what does the Gauss divergence theorem says? Surface integral f dot n cap ds is equal to del dot f dv. Gauss divergence theorem is nothing but transformation between surface and volume integral. So we have f as yixj plus zk. So let us find the divergence of f. We have f here yi plus xj plus zk. So divergence of f will be, so in this case f is okay. So del dot f is del by del x y plus del by del y x plus del by del z z, which is 0 plus 0 plus 1, that is 1. So now let us put this value of del dot f here. Okay, so f dot n cap ds is equal to volume del dot f dv is equal to 1 dv v, so which is equal to volume, and where v is the volume of the cube. Since the cube is unit cube, so volume is also 1 L cube. Length into breadth into height, so L cube is equal to 1, so answer is 1. Okay. Right. Let us go to the next problem. So the line integral of function f in the counter clockwise direction along the circle at z is equal to 1 is. Since the question is on line integral, so we can use Stokes theorem here. So by Stokes theorem we have f dot dr is equal to surface integral del cross f dot n ds. So where f is given as yzi, so let us find out the curl of f. Okay, I cap, j cap, k cap, del by del x, del by del y, del by del z, okay, yz, 0 and 0. Now 0, okay, 0 minus y plus k cap, 0 minus z, right? So which is equal to 0 I cap. yj cap minus zk cap. So now applying Stokes theorem, surface integral del cross f dot nds n cap ds is equal to surface integral yi, okay, so this is yj minus zk cap, okay. N is a unit normal vector of surface S. So here in this case surface is the circle x square plus y square is equal to 1, which lies in xy plane. So unit normal vector lies in z direction, that is k cap. So k cap ds. So again so yj cap dot k j cap dot k cap is, since the angle is 90 degree, so cos 90 is 0. So this is 0 and minus z k cap dot k cap is minus z. K cap dot k cap is 1 since cos 0 is 1. So minus z ds. Now since surface area of, okay, so since z is given as 1 and surface area is pi r square, where S is the surface area of x square plus y square is equal to 1, which is a circle, and radius is 1, so pi r square is just pi. So we have minus 1 to pi, which is minus pi. Right? So B is the answer. Let us see the next question. The volume enclosed by the surface Ex over the triangle bounded by the lines x is equal to y, x is equal to 0 and y is equal to 1 in the xy plane is. So let us draw this triangle. Okay, so we have xy plane. So 0, 0 and x is equal to 0, y is equal to 1. So x is equal to 0 is y axis itself. So let us change the color. So this is x is equal to 0, y is equal to 1 and y is equal to x. So intersection point is 1, 1. This is 0, 1. Okay, and let us drop a line here. So 1, 0. Yes. So now we have to find the volume enclosed by the surface over the triangle. Okay. So required volume is fxy dx dy, right? If this is O, this is A and this is B. We are interested in OAB, so which is double integral e raised to the power x dx dy, because this is confined in xy plane. So now you can choose here either horizontal strip or vertical strip. In horizontal strip y is constant, in vertical strip x is constant. So let's choose vertical strip here, of with dx. Okay, so this will become dy dx where y varies. Now let us set the bound. So lower limit is, so y is varying as x, so this line is y is equal to x, right? So y is equal to x and it goes up to 1, y is equal to 1, so which is a constant, so 1, and again x is constant, so which varies from, so this slider is varied from OB to A, so which is from 0 to 1, so x is equal to 0 to 1. Yes, so now this is equal to e raised to the power x y. Okay, since we are integrating this with respect to y, so now this is a constant, so ex into y, which varies from x to 1, right, dx, and x is equal to 0 to 1. Again x varies from 0 to 1, ex 1 minus x dx. So again integrate this with respect to x. So we have ex minus x ex dx, x is equal to 0 to 1. So which reduces to ex 0 to 1 minus ex x minus 1 0 to 1. Okay, so which is e raised to the power 1 minus 1 minus 0 minus of minus 1, so which is e minus 2. Okay, so value of e is 2.71 approximately, minus 2 which is 0.71. So answer is 0.71. So you can take 0.718. So answer is 0.718. Yes. So now let us take horizontal strip. Okay. So now let us take horizontal strip. So if we take horizontal strip here, okay, of width dy. So in horizontal strip y is constant and x varies from 0 to x is equal to y. So lower limit of, so you can write this as ex dx dy, x varies from 0 to x is equal to y. Okay, and y varies from 0 to 1, 0 to 1. So now this is e raised to the power x 0 to y 0 1 dy. So which is e raised to the power y minus 1 and 0 to 1 dy. So again e raised to the power y minus y, so 0 to 1, so which will be equal to e minus 1 of minus 1, which is e minus 2 again. So whichever way you choose, either horizontal strip or vertical strip, you will get the same answer, right? Okay, so let's go to the next problem. The scalar potential phi has the following gradient. Consider the integral on the curve. The curve C is parameterized as follows, right? We need to find the value of integral. So by inspection, we find that here independence of path is applicable. This is on the independence of path theorem. So where we are given gradient f as, gradient f is given yz I cap plus xz j cap plus xy k cap, right? So where, okay, so gradient, this is gradient, phi. So now phi will be equal to, see, you can integrate this with respect to x, so which will be xyz, or this with respect to y, which will be again xyz, and xy with respect to z, so xyz. So phi is xyz, and now this implies we can apply independence of path here. So to find the value of integral, we can choose, so here x is equal to, y is equal to t, and z is equal to 3t square. So let us put the value of phi, so which is t dot t square into 3t square, okay, 3t square, so which is equal to 3t raised to the power 5, okay, and t varies from 1 to 3, yes. So we will have 3 raised to the power 5 minus 1 and 3. So answer is 726. Okay, so the value of integral is 726. Let's go to the next problem. The integral where d denotes the disk evaluates 2. Okay, so this is a circle, the disk is a circle with radius as 2. So by inspection we see that we can use polar coordinates here. Okay, so let us put x is equal to r cos theta and y is equal to r sin theta. So dx dy will be equal to r d theta. Okay, so now we have, let us put value of x and y. So we will have r cos theta plus r sin theta, okay, plus 10 and r dr d theta. So here, okay, so let us put x and y as r. So r square cos square theta plus cos sin square theta, which is 1, is less than equal to 4. So r is less than equal to plus minus 2. Okay, so since we are taking polar coordinates here, so and this is r is nothing but radius, so we will take the consider the positive value. So r varies from 0 to 2, right? R varies from 0 to 2 and theta varies from, since this is a circular disc, so you can draw this circular disc in the xy plane. So this is 2 here, okay, radius, and so theta varies from 0 to 2 pi, okay, 0 to 2 pi. So now r is equal to theta is equal to 0 to 2 pi, and we have one by 2 pi outside. So now integrate. See, for constant limits, it hardly matters whether we first integrate with respect to r or with respect to theta. In Cartesian coordinate, with respect to x or with respect to y. Okay, so let us first integrate with respect to r. So this is r square cos theta plus sin theta. So cos theta plus sin theta, r square, so r cube by 3, okay, and varies from 0 to 2 d theta plus 10 r square by 2, 0 to 2 d theta, and now theta varies from 0 to 2 pi, and here theta varies from 0 to 2 pi. Okay, and outside 1 by 2 pi. Okay, so now this reduces to 0 to 2 pi, 8 by 2 raised to power 3, 8 by 3 cos theta plus sin theta, one by 2 pi plus 1 by 2 pi. Okay, so 4 by 2, right, into 10, so which is 5 into 4 d theta, 0 to 2 pi. Okay, 1 by 2 pi, 8 by 3, so integrating cos theta, which is sin theta, and sin theta is minus cos theta, so 0 to 2 pi plus 1 by 2 pi. So since this is a constant, so we have 20 into 2 pi minus 0, so which is 20 into 2 pi. Okay, so which is cancelled, and here sine 2 pi is 0. Okay, and cos 2 pi is 1, so 0 minus 1, and sine 0 is 0, cos 0 is 1. So 0 minus 1 minus of 0 minus 1, okay, which is 0. So we are left with only 20. So answer is 20. Okay, so let's go, answer is 20. So let's go to the next question. The value of the line integral along a path joining the origin and the point, okay, 1, 1, 1 is. So when 2 points are mentioned, find the relation in terms of the third variable in terms of x, y and z. So let's say we have, so x minus x1, x2 minus x1 is equal to y minus y1, y2 minus y1 is equal to z minus z1 by z2 minus z1 is equal to t. Let us take that parameter as t. So put the value of x, y and z and use the endpoints of one variable, okay, which is t, right? So here x, x1, y1, z1 is 0, 0, 0 and x2, y2, z2 is 1, 1, 1. So we have x minus 0 by 1 minus 0, y minus 0 by 1 minus 0 and z minus 0 by 1 minus 0, which is equal to t. So x is equal to y is equal to z is equal to t, right? And so since x, y, z are varying from 0 to 1, so t is also varying from 0 to 1. So now, so this reduces to 2xy square plus 2x square plus 2x square y dy plus dz. So let us replace the value of x, y and z. So 2t cube dt plus 2t cube dt plus dt, and where t varies from 0 to 1. Okay, so now, so which is 4t cube dt plus dt. So 4t raised to the power 4 by 4 0 to 1 plus t 0 to 1, so which is equal to 1 plus 1 and equal to 2. So 2 is the right answer. Now let's go to the next problem. The line integral of the vector field along a path from 0, 0, 0 to 1, 1, 1 parameterized by t, t square, t is. So x is t, so if dx, so x is t, so dx is equal to dt, and y is t square, so dy is 2t dt, okay. So z is t again, so dz is equal to dt. Now f dot dr is equal to, so replace x by t, so and z by t, so 5t square dt and 3t square plus 2t square, okay, and 2t dt. Zero to 1 5t square since x, y, z, x is varying from 0 to 1, so t is also varying from 0 to 1, okay. and y square is varying from 0 to 1, so t is varying from 0 to 1, and similarly, so t is varying from 0 to 1, that is why I wrote 0 to 1, and 5t square dt plus 3t square plus 2t square, because here it is 3x is t, y is t, 3t square plus 2t, and dy is 2t dt plus z is t square t means t cube dt Okay, so now this is 5 t raised to the power 3 by 3 and 1 to 0, so 5 by 3 plus this is 3 t raised to the power 3 by 3, so which is again 3 by okay, this is 2t also here, so 3t cube 6t cube, so 6t cube by 3, 6t cube, so 6t 4 by 4 plus this is 4t4 by 4 plus varies from obviously 0 to 1, and this is t raised to the power 4 by 4, so now 5 by 3 plus this is 6 by 4 plus 6 by 4 plus 1, so this 4 gets cancelled, so 1 plus 1 by 4, so which is equal to 5 by 3 plus 11 by 4. Okay, so 53 by 12, which is 4.41. Okay, next is let I is equal to, where R is the reason shown in the figure and C is equal to 6 into 10 raised to power minus 4, the value of I equals. Okay, so this is again a problem on double integral. So here let us consider vertical strip. Okay, with dx, which is where x is constant and y varies from y is equal to 0 to y is equal to, okay, let us find the equation of this line. So equation of a line with 2 points is y minus y1 is equal to y2 minus y1 by x2 minus x1 x minus x1. So here this point is 1, 2, so x1 y1, and this point is 5, 10, so which is x2 y2. So now y minus 2 is equal to 10 minus 2, 8, x2 minus x1, 4, and x minus 1. So which is y minus 2 is equal to 2, x minus 2, so y is equal to 2x. So this line is y is equal to 2x. So now we can write this as double integral xy square dy by dx. So where y varies from 0, so lower limit is 0 and upper limit is 2x. So y is equal to 0 to 2x. So y is the dependent variable and x is constant. So x varies from 1 to 5. Right? So again, let us differentiate this with respect to y first. So x y cube by cube 3 0 to 2x dx. Okay, x is equal to 1 to 5. So okay, here c is missing here in the question. So originally in the question c is mentioned here, where c is given as 6 into 10 to the raised to the power minus 4. So now, so this is c here, c is constant. Okay, so c 8 x raised to the power 4 by 3 dx. X varies from 1 to 5 and c dot f by 3 x raised to the power 5 by 5. Okay, 1 to 5. So c 8c by 3 5 raised to the power 5 minus divide by 5, which is 5 raised to the power 4 minus 1 by 5, so which is equal to 8c by 3 625 minus 0.2. So and let us put the value of c, which is 6 into 10 raised to the power minus 4 into 625 minus 0.2. So if you evaluate this, so you will get 0.996. Okay, so up to 2 decimal places. Answer is 0.99. Okay, next problem. So let I is equal to where x, y, z are real and let C be the straight line segment from point A to point B. The value of I is. So let us find the relation in terms of the another variable in terms of x, y and z. So x minus x1, x2 minus x1, y minus y1, y2 minus y1 and z minus z1 by z2 minus z1, which is equal to say t. So put the values of x, y and z and use the endpoints of one variable, which is t. We have taken t here. Okay, so this is x1, x2, y1 and z1, x2, y2, z2, right? So x minus 0 by 4 minus 0, y minus 2 by 1 minus 2 minus 1, z minus 1 by minus 1 minus 1 minus 2. So x is equal to 40. Okay. So dx will be equal to 4 times dt. Similarly, y is equal to minus t plus 2. So dy is equal to minus dt. Again, z is equal to minus 2t plus 1. dz is equal to minus 2 dt. Okay, and right. So if x varies from 0 to 4, then t will vary from, so put x is equal to 0 here, t is 0, and put x is equal to 4 here, then t will be equal to 1, right? Similarly here y varies from 2 to 1, so if you put 2 here, it will t is 0, and if you put 1 here, so t will be equal to 1. Okay, so t varies from 0 to 1. Now let us write integral okay, so we have 2z. So let us put the values of x, y and z here in this I. So 2 times z, which is minus 2t plus 1, and dx, which is 4 dt, and 2 times y dy, so 2 times minus t plus 2 minus dt, and 2x dz, so 2 times 4t, that is 8t, minus 2 dt. Okay, so dz is equal to minus 2 dt. So now evaluate this integral from 0 to 1. So if you evaluate, this becomes minus 30t plus 4 and dt, 0 to 1, so which gives minus 11. Okay, so minus 11 is the right answer. Right? Okay, let's go to the next problem. As shown in the figure, C is the arc from point 3, 0 to the point 0, 3 on the circle with radius 3. The value of the integral is, okay. So here by inspection we see that we can use polar coordinates here. So let us put x is equal to r cos theta, or we have radius 3, so 3 cos theta, and y as 3 sin theta, right? So dx is minus 3 sin theta d theta, and dy is 3 cos theta d theta, and theta varies from c0 to pi by 2. So let us put the value of x and y, okay, as 3 cos theta and 3 sin theta respectively. So we will get y square plus 2xy, okay, dx plus 2xy plus x square dy, okay. So 9 sin square theta plus 18 sin theta cos theta and minus 3 sin theta d theta plus 18 sin theta cos theta plus 9 cos square theta and 3 cos theta d theta. 0 to pi by 2, theta varies from 0 to pi by 2. Again this is 0 to pi by 2 minus 27 sin cube theta, okay, d theta, or we can write that at the end, and plus minus 54 sin square theta cos theta, right, plus again 54 sin theta cos square theta plus 27 cos cube theta, yes, d theta. Okay. If you evaluate this, it becomes 0. Okay. So now we could have used Green's theorem here. Okay. According to Green's theorem, we have, say, we have f1 dx plus f2 dy, okay, is equal to surface integral del f2 by del x minus del f1 by del y. Okay, dA or dx dy, right? So here f1 is equal to y square plus 2yx and f2 is equal to 2xy plus x square. So del f2 by del x will be equal to 2y plus 2x. So 2y plus 2x and del f1 by del y is equal to, okay, this was y square, right? Del f1 by del y will be equal to 2y plus 2x again. So 2y plus 2x minus of 2y plus 2x, right? So which gets cancelled and dA. So this is 0. Yes, so this was the second method. This was the first method and this was the second method using polar coordinate. Right? Okay, let's go to the next problem. Given f is equal to x square minus 2y I cap minus 4y z j cap plus 4x z square k, the value of the line integral along the straight line. Okay, this is again from again on the line integral. Okay, so we have just solved this kind of problem. Okay, so here x1 y1 z1 is 0 0 0 and x2 y2 z2 is 1 1 1. Okay, so now putting the value, you will get x is equal to y is equal to z is equal to t. Okay, now f dot dl is equal to, now replace xyz with by t. So t square minus 2t and minus 4 t square plus 4t cube into dt, and dx is equal to dy is equal to dz is equal to dt. So you can write this as t square minus 2t minus 4t square plus 4t cube dt, and t varies from, since x y z is equal to t, so t also varies from 0 to 1. Since x y z, all of 3 varies from 0 to 1. Okay, so t square, integral t square is t cube by 3, 0 to 1 minus, okay, this is minus 3t square, so you can write minus 3 outside, right? minus 2 t square by 2 0 to 1 plus 4 t raised to the power 4 by 4 0 to 1. This reduces to minus 1 and plus 1 is equal to minus 1. Okay, so answer is minus 1. Okay, let's go to the next problem. Consider the integral being, consider the line integral. The integral being taken in a counterclockwise direction over the closed curve C that forms the boundary of the region R shown in the figure below. The region R is the area enclosed by the union of a 2 cross 3 rectangle and a semicircle of radius 1. Okay, the line integral evaluates to. Okay, again using Green's theorem. Okay, let us write the formula. So Green's theorem, according to Green's theorem, says f1 dx plus f2 dy is equal to surface integral del f2 by del x minus del f1 by del y dx dy. Okay, so here f1 is given as x and f1 is given as minus y. So f1 is minus y and f2 is x. So del f1 by del y is equal to minus 1 and del f2 by del x is equal to plus 1. Okay, now putting the values of del f1 by del y and del f2 by del x in the Green's theorem. So minus y dx plus x dy is equal to double integral 1 minus of minus 1 dx dy, or you can write this as area dA. So which is plus 2, 1 minus of minus 1, 2 into area. And area can be evaluated from this figure. So this is a rectangular, so we need to find this area. Okay, so this is a rectangle with length has 3 and breadth has 2, so 6. This has area 6 units, and this semicircle has area pi by 2 r square. So radius is 1 here. Yes, 4 to 5, 1 unit. So pi by 2 units. So 2 into 6 plus pi by 2 units, which is 12 plus pi. Yes. Okay, 12 plus pi. Okay, let's go to the next problem. A vector field is defined as plus this, and where I, j, k are unit vectors along the axis of a right-handed rectangular Cartesian coordinate system. The surface integral f dot ds is an elemental, so where ds is an elemental surface area vector evaluated over the inner and outer surfaces of a spherical cell formed by two concentric spheres with origin as the center and internal and external radii of 1 and 2 respectively is. So we can rewrite this as x by root under weight. Okay, so 1 by root under x square plus y square plus z square and whole cube. Okay, and xi plus yj plus zk, right? So this is nothing but r vector by, and this is r cube. Okay, so now okay, from Gauss divergence theorem we have surface integral f dot ds is equal to volume integral del f dx dy dz or v. Okay, so we need to find divergence of f here. So divergence of f or divergence of f r by r cube, we can write this as partial derivatives del by del x by r cube plus del by del y by r cube plus del by del z by r cube. Okay, now let us evaluate first del by del x by r cube, which is nothing but x square plus y square plus z square 3 by 2. Okay, so now this is in the form of u by v. So differentiating this, we have v, so x square plus y square plus z, if this is u by v form. Okay, so by z plus z square 3 by 2. Okay, v du, u is x, which is 1, minus u dv. So differentiating this with respect to x, taking as y and z constant. Okay, x square plus y square three by 2 x square plus y square plus z square 3 by 2 minus 1, so 1 by 2 into 2x whole divided by x square plus y square plus z square by v square, so 3 by 2 into 2, so only 3, right? So if we take x square plus y square plus z square 1 by 2 as common, so we will have x square plus y square plus z square minus 3x square by whole divided by x square plus y square plus z square 3. Okay, so now y square plus z square minus 2x square by x square plus y square plus z square. So if you take this in the denominator, so this will be 5 by 2. Okay. Similarly, if you evaluate del by del y by r cube, so you will get let me write here. There is no space. So del y y by r cube is equal to z square plus x square minus 2y square by x square plus y square plus z square 5 by 2, and del by del z by r cube, you will get x square plus y square minus 2z square by x square plus y square plus z square 5 by 2. Now putting the values of partial derivatives in the equation. Okay. So y square plus z square minus 2x square y square plus z square minus 2x square plus z square plus x square minus 2y square plus x square plus y square minus 2z square. Okay, so here 2y square plus 2z square plus 2x square, 2y square plus 2z square plus 2x square minus 2x square minus 2y square minus 2z square whole divided by raised to the power 5 by 2, x square plus y square plus z square raised to the power 5 by 2. So this reduces to 0. Okay, so now we got del dot r by r cube, divergence of r by r cube is equal to 0. So by divergence theorem, surface integral f dot ds will be equal to 0. Okay, so 0 is the right answer. So remember this result, that divergence of r by r cube, remember this result. Okay, that's all for today. I will be starting calculus in the next lecture, so stay tuned, keep practicing, keep preparing, and thank you.